So as your application evolves, supporting multiple types of clients like desktop, mobile apps, etc. becomes very tricky. The backend becomes complicated and you start applying a lot of hacks to serve them properly. In this video, we take a look at an interesting high-level architectural pattern used in microservices that solves this exact problem. And the pattern is called backend for frontend, fondly called as BFF. We would see in detail what this pattern is all about, where it is actually used, how to implement it, look at its advantages and disadvantages, and conclude by building an understanding of when should we actually start using it. But before we move forward, I'd like to talk to you about a course on system design that I've been running for over a year now. The course is a cohort-based course, which means I won't be rambling a solution and it will not be a monologue. Instead, a small focused group of 50-60 engineers every cohort will be brainstorming systems and designing it together. This way, we build a solid system and learn from each other's experiences. The course to date is enrolled by 600 plus engineers spanning 9 cohorts and 10 countries. Engineers from companies like Google, Microsoft, GitHub, Slack, Facebook, Tesla, Yelp, Flipkart, Dream11 and many more have taken this course and have some wonderful things to say. The coolest part about the course is the depth we go into and the breadth we cover. We cover topics ranging from real-time text communication for Slack, to designing our own toy load balancer, to ClickBuzz's live text commentary, to doing impressions counting at scale for any advertisement business. In all, we would cover roughly 28 questions, and the detailed curriculum split week by week can be found on the course page, which is linked in the description down below. So if you're looking to learn system design from the first principles, you will love this course. I have 2 offerings for you. The first one is the live cohort based course, which you see on the left side, and the second one is the recorded course, which you can see on the right side. The live cohort based course happens every 2 months and it will go on for 8 weeks, while the recorded course contains the recordings from one of the past cohorts as is. If you are in a hurry and want to binge learn system design, I would highly recommend you going for the recorded one. Otherwise, the live cohort is where you can participate and discuss things live with me and the entire cohort and amplify your learnings. The decision is totally up to you. The course details, prerequisites, testimonials can be found on the course page arpitbhai.me/masterclass, and I would highly recommend you to check that out. I put the link of the course in the description down below. So if you are interested to learn system design, go for it. Check out the link in the description down below, and I hope to see you in my next cohort. Thanks. So say you have a monolith that serves all the APIs that your clients ever need. And that API, you expose it through your favorite web server, and what you support right now, you support only one type of client, a desktop web interface is what you're supporting. So given that as your current situation, your typical 3-tier architecture would look something like this. You would have your users, which are talking to your monolithic APIs, which are then, which in turn fires the query to the database, gets the response and sends it back to the user. A very standard 3-tier architecture that you will have, right? And to take more concrete example, let's say you are building an e-commerce app, right? And in this e-commerce app, what you need is you have an API that sends product details. So on the web page, what you are displaying the detail about the entire product, so that person, if he or she would want to purchase, click on that button, makes the purchase. But to make that informed decision, you send all the details. All the details might include the name of the product, the description about the product, the different sellers that are selling that product so that you can render the drop down, variants of a product. For example, if you're selling a t-shirt, red, blue, black, green, violet, purple and whatnot. So those variants you might want to store. FAQs, a bunch of FAQs are there that you render it on the web page. You might also want to render that. And reviews. Let's say the product has 1000 reviews, you might pick top 50 and you would want to render it so that it helps people make very informed decision if they would want to purchase that product or not. Now what you might do is you might expose an endpoint that looks something like this, /v1/product/product ID. Firing a GET request on this would give you this entire detail, right? So all of this is what you're sending in one API response. Because when you do this in one API, like you might think, hey, let me fetch reviews separately, let me fetch FAQ separately, let me fetch something else separately. When you do this, the problem that would happen is your client would have to make a lot of network calls. You don't want that to happen. So what you'll do, you'll expose a single API. You'll expose a single API which makes an HTTP request. Internally, it may do whatever it wants to do. Because it's a monolith, it goes to one place, gets the detail and sends it back. If it was microservices, it would have made multiple calls to multiple microservice, get the details and send it back to the user. Irrespective, for your client, it is just one request which is exposed from this monolith or from your front-facing proxy that you have. Now, when that happens, every single thing that the page required, you're exposing it on that endpoint, which is get/v1/product/product ID. Right? Now, this is very straightforward to do it because you're only supporting one client. Now, what if you foray into mobile? What if now you are also having a mobile application? So, mobile application might look, your mobile application has a critical thing to note here. Your mobile application has a very limited real estate. Like your screen size is small. You have very small place to show all the information that you would want to show. So, on your desktop web, there is a lot of real estate. You can render a lot of information which is seemingly non-critical, but you have space, so you would render it. You might want your page to look filled. Right? So, when you foray into mobile, you have now two types of clients to support, your desktop web and your mobile app. Right? Both of them, if they invoke the same product endpoint, get/v1/product/product ID, and both of them would get the same set of information. But if you think about it, the information that we sent to desktop web was okay for us to render the entire page. But on mobile screen, you don't have that space to render that stuff. So that is where, let's say, you might want to skip all the reviews. You don't want to show them because you might have a button show reviews, clicking on which might take you to a different screen, and on that you might want to render the reviews. Right? Similarly, FAQs can also go to the next screen. So that what you show in the front face, on the front viewport that you get, it should be the most critical information that you have. You would show the user the most essential, most critical information that he or she needs to make the product decision. A lot of things might be non-critical per se. So you should be moving that to a different screen, right? So because that you are not rendering that information in the first viewport, why to even send it in the API response? So what would happen with that is, if you are using the same endpoint that you used for desktop web and your mobile app, you are sending a lot of extra information with it. For example, because you decided that you will show reviews on the next screen, you will show FAQ on the next screen. So why do you want to even send that, right? So if we just want to ensure the great user experience with very low network bandwidth being consumed and being very efficient on your mobile device, you should be sending only the data that your mobile is definitely going to use to render the screen. This would help you save network bandwidth, processing power of your mobile, battery of your mobile, memory and whatnot. Plus, it would load your page very quickly because now there is a very small amount of data that your mobile needs to process and render. So it's very efficient. So that is where, to give a great user experience, you might want to have different set of responses depending on different types of client that are coming in. And just to extend this problem, it's not just limited to mobile apps. This problem, like for example, you have a desktop app, you have a mobile app, but now let's say you would want to create an Alexa plugin. And you can do that. If you'd want to have an Alexa plugin, the kind of responses Alexa would need is very different. The format in which it would need is very different. It is not the same format. Like the JSON that you sent in the response of product details is not how Alexa would understand what to communicate. It would have its own format in which it would be expecting the result, right? So different types of clients might have different types of requirements. A very naive way of implementing this would be, hey, in my API request or in my exposed endpoint, let me accept query parameters which says that, hey, !platform is equal to web, platform is equal to app, platform is equal to Alexa. For example, if you are doing that, You're adding so much of ifs and else's and so much of complication in your backend unnecessarily, right? So is there a better way to solve it? A better way to solve it is through a pattern called backend for frontend. What backend for frontend does is it creates, like, it keeps your monolith as is. You don't have to apply any hacks on monolith. Keep your monolith as is. What it would do is, imagine your monolith is very generic. It gives you, every time gives you all the information that you ever need without anything being filtered out. The filtering happens at your BFF layer, your backend for frontend layer. The idea for this is your desktop APIs, your desktop clients, your desktop web would invoke APIs that would go to desktop BFF. Desktop BFF would then talk to monolith. Monolith then talks to DB, get the data, send to the BFF, and BFF forwards it to the desktop client. Similarly, requests from your mobile devices would go to mobile BFF. Mobile BFF goes to monolith. Monolith goes to database, gets the response, sends to BFF, and which is then sent to user. At this layer, at this BFF layer, what you change, you don't apply any logic. The BFF is simply going to be the presentation layer. For example, whatever information it got from the monolith or from the backend APIs, it would filter out the things that it does not need to send to the corresponding type of client. So desktop BFF or mobile BFF, or in general your BFF service, would only take care of the presentation part of it. That, hey, what I need to send, what I don't need to send, if I'd want to make something extra call into some another backend microservice to get some information, it will only take care of the presentation layer. It would not have any business logic, not at all. Right? So this is the advantage, or this is what the BFF pattern is all about. It sits between your core backend system and your client, acts as a proxy for a corresponding type of client, and all the presentation hacks go there. Right? They're very similar to API gateway, the API composition pattern that we saw earlier. It's very similar to that. And each BFF, you can consider each BFF as your API gateway. Right? So multiple BFF is equal to multiple API gateways that you have, one for each type of client. Right? So now what would happen is, instead of having a single point of entry into a system, earlier what used to happen, your client used to directly call monolith, monolith used to call DB, and done. But now you have multiple points of entries for each type of client. They're talking to each of the BFF, and BFF is internally making calls to other services. Right? So BFF does a lot of fancy things. So it needs to know, like every single BFF decides, given an API request that is coming to it, what it needs to fetch, how it needs to fetch, and what it needs to send in the response. It needs to have all of these three configurations in it. But if you look at it, all of these three are purely presentational. They are not business logic. They are just presentational on what it needs to fetch, how it needs to fetch, and what it needs to send in the response. Purely presentational. It purely works on the presentation layer of your data. Right? Might fetch extra information here or there, but that is not a business logic. That is still a presentation logic. Right? So here, your mobile BFF would have a very big job. Let's say you are fetching a product detail. Your request from your mobile app goes to mobile BFF. Mobile BFF talks to monolith, gets this gigantic response, and then decides to drop reviews, FAQs, and other stuff that it does not want to send to the mobile. Right? So that's where BFF comes in handy. But now you'll have one question. But why are we even fetching the data from the backend if we are eventually going to drop it? No, we are keeping our backends very generic. Plus, with this being so generic, it's very easy to cache. It's very easy to cache our entire response, other than saying if this is there, then cache this. If this parameter is there, then cache this entire response. It's very simple to keep your backends very generic while having a BFF layer that takes care of the presentation depending on the client. Okay. Up until now, we looked at the backend being a monolith. This also works very well if your backend is microservices. So for example, in the same e-commerce application, you might not have a monolith. You would have a bunch of microservices. Right? I'll give a very nice example here again. So you have a desktop app. You have a desktop web and a mobile app, right? Now, in microservices architecture, what you have is you have your product detail service, which gives you the detail of a product. You have a seller service that gives you seller information. You have a review service that gives you the top reviews for a particular product. And then you have augmented reality experience, right? Now, what you need to do is the request from your request from your desktop web comes to a desktop BFF. In order for desktop BFF to gather that information that needs to be rendered, it would have to talk to your product detail service, seller service, and review service to grab all the information and send it out to the user, right? When the request comes from your mobile app, goes to mobile BFF, it would fetch product detail, seller detail. It does not need to fetch review service. It does not have to talk to review service because it is on the next screen. So only product detail, seller detail, but mobile, because it has accelerometer, it can, or it has AR support, you can talk to AR service and get the necessary information so that you can literally place the object that you are buying. Let's say you are buying a chair. It would give you that sense that, hey, chair is right here through the lens of your camera, right? So AR experience might not be suitable for desktop web, but would be very suitable for mobile. So this is an advantage that we get. This who to talk to only, the logic only has to be with the corresponding BFF layer, right? So that's why it fits very beautiful in the microservices based architecture. Now let's take a look at advantages of BFF service or of BFF layer. First of all, it gives you support for multiple isolated interfaces. So the idea here is your desktop layer does not need to know your mobile layer. It gives you ability to support multiple isolated interfaces that does not interfere with each other at all, right? Your client specific tweaks are much faster to push. Like for example, if tomorrow your Android team says or your mobile team says, hey, we also need this information, it is very easy. You don't need to change your monolith or your backend services. They can send the same set of response that it was sending to anyone and everyone. On your BFF layer, you can tweak that thing. Hey, now also send this information or also stop sending this information. Those tweaks are much, much faster. Third is hiding sensitive information. For example, you might not want to send a particular sensitive information due to anything, like your backend is generating that, but you would want to filter it out on your BFF layer. You can do that. Your backend is not directly exposed to your end user. So now you can filter out the things that you don't need, hide sensitive information. Then picking the right stack for your protocols for your client. And it's not just for client, but even for backend. Because you have a BFF layer sitting in between. Let's say you have a legacy client that only understands XML, but your backend is sending response in JSON. Your BFF layer can do the transformation because for a particular type of client, it only understands XML. So I'll take JSON, convert it into XML and send it back to the client, right? Then you might also pick the best network stack, TCP, UDP, WebSocket, gRPC, HTTP1, HTTP2, whatever you would want to do. You can pick that depending on what works the best for the client. Your backend can remain as is, right? Also, this also applies on BFF to microservices layer. So when BFF interacts with the backend services, you can pick the best protocol out there. For example, you can use a very crude gRPC because BFF is also server in your infrastructure, microservice is also server in your infrastructure. That could be very lightning fast communication with the best, most complicated protocol that you could think of that gives you the best performance out there. Your user does not, like for example, your client would not know what gRPC is. Like your desktop browser would not know gRPC is. BFF, because it's a server, BFF to microservice communication can happen over gRPC, right? Big advantage that you'll get. Next advantage is improved security. And now earlier we talked about hiding sensitive information, but this is about improved security. For example, depending on the types of clients that you have, different types of attacks are possible. For example, the attacks that are possible through mobile device are very different from attacks that are possible through web interface. Right? So depending on the client that you have, you might want to apply the corresponding checks onto your BFF layer. And that makes it very easy. You don't have to apply all the checks at all the layers. Right? You can apply very specific client or very client specific security checks at your corresponding BFF layer, ensuring that no that no information is breached or no user is at stake. Right? Next is you need a single general purpose backend for everything, and BFF can take care of a customization. This is a very big advantage because now your backend, the core backend that you have, can send all the information. It is very generic in nature. Now anyone who needs any specific details or does not need any specific detail can just filter out at the BFF layer. This is very beautiful optimization, because this would ensure your backend, it makes your life for backend very simple. Caching of your responses on backend is very simple because it's not doing filter outs. Filter outs is happening at BFF layer. So your backends are very performant on the caching side. The final advantage that we take a look at is BFF can also act as a request aggregator. Because BFF is sitting in between, and let's say you have multiple microservices, your client does not have to talk to individual microservice to get the information. It can just make one API call to BFF. BFF can act as an aggregator, similar to how API gateways are. Same thing, because BFF are like API gateways. Request comes to BFF, BFF fans it out, gets the response, gathers it and sends it back. Right? So BFF can also act as a request aggregator, making your clients very lightweight. Just one API call from them, we are fanning out a lot of calls internally. Right? Solid advantages that you get by using BFF pattern. Right? But obviously grass is not always green. There are disadvantages. The first disadvantage is fan out. Although that I just talked about as an advantage of BFF, it also falls as a disadvantage of BFF, because now if we think about BFF doing the fan out, it is very network heavy process. Right? So BFF might become very bloated over time, where it has to talk to a lot of services doing a lot of things, and every call that it makes to a microservice is a network call. Very expensive in nature. So you would have to provision your BFF in such a way that it could support large number of concurrent network calls. Second, the language that you would pick or the tech stack that you would pick for BFF has to be very proper. For example, you should not be using Python to create your BFF, because you would want concurrency. You would want ability to fire multiple network calls. Like when I'm talking about Python, I'm talking about Python 2.7. Python 3 with async IO you can still use. So your tech stack has to be very limited, which supports multiple concurrent network calls efficiently. That's what you would want to use. Right? So that is a not disadvantage but a challenge that you need to ensure like you should be using this. Second is code duplication. You could see that mobile, desktop, multiple types of client, they would be interacting with similar set of services, just skipping a few here or there. So most of the code across your BFFs for different client would be very similar. So there is a risk of there will be code duplication. So now if you change a logic at one place, you have to ensure that all the BFFs get those changes. So might be a little tricky over time when your BFF code becomes complicated, where you would have to do or changing in one, you might need to roll out changes for all the BFFs out there. Next is you are adding more moving parts in your infrastructure. Now with this new BFF layer sitting in between, there is this new component that needs to be managed, maintained, monitored and deployed. Again, a big pain point with large set of infrastructure, large number of services. You would have to ensure that all of these things are managed, maintained, monitored and deployed, because you cannot have blind spots in your system, might lead to a big outage. And with this proxy layer, with this BFF layer sitting in between, it would increase your latency slightly, because you are making a call to one service that internally makes call to multiple services to get the data and send it back, adding that one extra network hop, but it's fine because the advantages that you get out of this are immense. But just to be wary that adding one network hop might not be the best decision if you are building something like a very super low latency application. If it's a normal REST based user web 2 use case like e-commerce and all, it's still okay. Or if you are building something very low latency, this might not be the best decision that you will take, right? So to conclude, when should we introduce BFF? Although it sounds super interesting to have BFF, but two specific cases when it should prompt you to think, this is the place where I should use BFF. First, when the interface are slightly different across clients. For example, where your interface for your web is very different from your interface in your mobile app. Like you are rendering 50 things over here, but only 10 things over here. It varies very huge. Like, so the variation is huge. When the variation is huge, that is a prompt point key. Can I use BFF over this? Because then you're unnecessarily fetching all the details from your backend and sending it to your mobile device, basically consuming the mobile data of your user, draining his or her battery, very poor user experience. Don't do that. This is a trigger point where you might think, hey, can I use BFF over here? Because your interface varies very slightly, your interface varies hugely. Because there is a huge variation, you should be using BFF in this case. Second is when your communication format of a client is very different. For example, if you have a legacy integration or a very specific integration which only expects you to send a data in a particular format. I gave an example of Alexa. That's a very good example for this use case. Like you'd want to send the product details, or you'd want to send the details on what's the shipping status of a product. Alexa might expect it in a certain format so that it can utter those voices or utter that sound and basically tells you about it. Right? It might expect response in a particular format, but you cannot change your backend and say, if Alexa written this format. That is a very poor implementation. Keep your backend generic. Have a layer for Alexa to say that, hey, when the request comes to Alexa layer, it goes to backend, fetches the generic information, transforms it into the format that your Alexa understands and sends it out. Right? Similarly, if you're supporting mobile device, it would go to the backend service, get the information, transform it, or basically filter out the things that it doesn't need and send it to the mobile. Another use case is, let's say you have a legacy integration, or let's say you're integrating, you have a very nice robust backend and you want to integrate it with a bank, right? Where you might want to directly talk to the bank and accept payments and whatnot. But that bank is built in a very legacy system. It understands the information in a particular format. Let's say XML. Hypothetical example. Let's say your bank understands XML. But every other client that you have, your mobile app, your desktop app, everything understands JSON. So what you can have just one layer of BFF that is specifically for XML. So you have a monolith. You have your user. Monolith exposes JSON endpoints. Client, all other types of clients understand JSON. They directly talk to monolith and problem solve. But your specific banking client understands XML. So you would add an XML backend for front end in between. So client that understands XML talks to XML BFF. XML BFF talks to monolith. It gets the data from the database, sends it into the BFF. It does the transformation of JSON to XML and adding or basically enriching the information or filtering out the information and sending it back to the XML client. So this way you can now support multiple types of client that understands totally different formats through a very simple and elegant solution called BFF. And yeah, this is all about backend for frontends. This is a very interesting pattern where you saw its advantage. You saw how useful it can be in order to power a very good user experience. So yeah, that's it for this video. I hope you learned something new. If you guys like this video, give this video a massive thumbs up. If you guys like the channel, give this channel a sub. I post 3 in-depth engineering videos every week, and I'll see you in the next one. Thanks, Ed.